the difference between union and structure here is the structure members will be having their own independent memory, whereas the union, all the members are going to share the same memory location. So that is the main fundamental difference between structure and union. Thus, all the identifiers of union have the same address. At any given point of time, only one member will be active. So these are the major differences between structure and union. So this is how we define the union, same as that of structure. Tag name will be there, different members will be there. So one example could be type definition, union, integer variable, double variable, and character variable. And for that we have created one variable called item. Now here id and c are called fields of union or members of the union. So no space is reserved as usual. When we declare the variables, then memory space will be reserved for this. Say for example, when I take one specific example, it will be clear. So declaration of union variable along with the memory representation. This is how it is shown in the memory. What I will do is, one second, the system is a bit slow. I'll just take the snapshots and I'll take these to paint. It will help me for the explanation purpose. Right, then later this is what is declaration. There is a main fundamental difference between structure and union. Right, so this is what is structure, what you can see. Union, how many members are there? 3 members, I, D, and C. So this is what happens when we declare a variable, because item is the name. What is happening here is item is the name of the structure, a union variable what we have created. Item is the name. Now with the help of that item union variable, we have created one variable x. What is x? X is a variable of type item. What is this item? This item is nothing but the union variable which is created by the union. Now item is referring to 3 entities, I, D, and C. So if this is the structure, what happens? Separate memory will be allocated. This is for I and this is for double variable and this is for character variable. So if this is a structure, the separate independent memory will be given for all the variables. So I will get this memory, D will get this memory, and C will get this memory. That is the case with the structure. Now when you talk about union, so what is the special property of the union? I'll come back to definition again for better understanding. All the members of the union share the same memory space. They will all start with the same memory location. That is the difference. If you can see here, this is what X, how diagrammatically it looks like. So X is shown diagrammatically. So C is a character type, it will take only 1 byte. D is a double, which is going to take 8 bytes. Then C is a I is an integer, which is going to take 4 bytes. So if you can see here, total 8 bytes are reserved for this same memory location that will be shared by all the members of the union. That means the same pen which is being used by 3 students for writing. So at a time only one can write, and after the completion of writing, the student will be passing the pen to another student. So the same thing is happening. Whereas if it is a structure, all the 3 students are having their own pen for writing. Independently they can write. Whereas here everyone is dependent. That means the same memory location will be used by 3 variables, by the C, I, and D. So because of that, what happens here is, at any, concentrate on this line, because of this, at any given point during execution, only one member will be active. You can access only one member. If you want, you can access only C or only I or only D. because same memory is being reused by all the members. Here independent memory will be there, here same memory will be used by all the members. Here same memory will be used by all the members. So because of that, only when one member will be active. Like when you have only one pen, it is understood that only one person can write with that pen. When one person is writing with the pen, other two persons will be idle, they will not be writing with the pen. If after completion of this, the next person will take the pen. Same way, in case of union, only one member will be active at any given point of time. So other than this, all the properties of union and structure are same. So only thing here is only one memory will be there, and that will be shared by all the members. This is how the unions work. This is what I have explained already. So this is on sample program which you can understand by yourself. The self explanation, like how we use, because I'll be covering those structures programs during the lab programs, and I explain in the lab programs. So wherever the fundamentals are required, that I will explain. So these are some of the differences between structure and union. So you'll be getting question like write the differences between structure and union. So based on what we have discussed, these are the few differences. Here we use struct keyword, and here we use union keyword for the union. So the memory will be allocated for each and every member in structure. That is, the compiler allocates memory for each member, and the size is sum of all the members. Like how we are saying here, if it is a structure, every member will get the independent memory. If it is union, the same memory will be shared by all the members. That is another difference. Value change of a member does not affect other member, whereas it is going to affect. Say for example, if it is a structure, if I change the value I to 5, it will not make any difference with D and C. But whereas here, if you write something here, that will be affecting other two variables also. It is going to overwrite. Say for example, now the variable I is using this memory with the value 5. Then later variable D will start using that value. The variable D will start using that memory with the value called 5.5. As there is only one memory which is being shared, then value of I will get erased. The value of I will get erased, and value of D will be active, because that is what is property of the union. Only one member will be active at any given point of time. That is what is property of the union. That is the property of the union. Right? Now the next difference here is, and the difference is, the address of each member will be in ascending order. So as I said, here the address of each member is same, because for every member addresses are different. When you consider this, for structure, every member has different addresses, because I is having different memory, D is having different memory, and C is also having different memory. Whereas in union, all the three variables are sharing the same memory location. So because of that, the memory addresses are same. Starting address is same for all the variables. Here starting address is different for all the variables. The individual members can be accessed at any time in case of structure. Why they can be accessed at any time? Because every member is having its own individual memory reserved. So when the individual memory is reserved, they can access their variable. The variables are accessible at any given point of time because memory is independent. Whereas in union, only one member can be accessed at any given point of time. So why only one member is accessed? Because the same memory is being used by all the three variables I, D, I, C, I, and D. So as same memory is being reused, then only one member can be accessed. So these are the few differences. This is what we have covered yesterday, self-referential structures. So when you come back to syllabus, after the unions, we have next entity called pointers and a dynamic memory allocation functions. Next entity what we have is pointers and dynamic memory allocation functions. So pointers, as you all know, these are the variables which contain addresses of other variables. So pointers are the variables which contain addresses of other variables. So I hope I need not explain in detail about the pointers, but still I'll cover briefly what actually is a pointer. So